Hey, what's up, guys? This is Chung here. So today, let's take a look at number 1388, pizza with 3n slices. So there's a pizza with 3n slices of varying size, and you and your friends will take slices of pizza as follows. And basically, if you pick any pizza, right, and then your two friends, Alice and Bob, will take the pizza on each side of this pizza, right? And there's a like, for example, if there's a 1, 2, 3, 4, 5, 6 pizza, right? For example, if you take number 4, so Alice will take number 3, Bob will take number 5. Same thing, right? Same thing for the other one. Let's say if you take number 6 here, so Alice and Bob will take number 1 and number 2. So which means that this is like a row, like a circle, right? And it's number 1 and number 6, they are connected to each other, right? And then it asks you what's the maximum possible sum of slices you can get, right? For example, if this we have a 1, 2, 3, 4, 5, 6 here, so the maximum we can get is 10. So how do we get 10, right? So the 10 is like this. So first we take mm, number 4. So once we take number 4, 3 and 5 is gone, right? So the only thing we can take is from 1 to or 6, and of course we'll take 6. That's why the total is 10, right? And here's another example here, right? And then there are some like constraints here. So the size of the length is within 500, and the length of the size uh, has to be can be divided by 3, right? And yeah, so that's the description of the problem. Actually, if you watch these things closely, and you can realize that, basically when once you take number 4 here, right? You cannot take number 4. I'm sorry. Once you take number 4 here, you cannot take number 3 here. All you can take is between 1 and 3, right? So this is kind of actually the problem is very similar like the house robber number 2, right? If you guys remember what does the house robber number 2 is that we also have like the array, right? And you cannot rob two consecutive house. And the same thing as this one. The last one, the first one, they are considered to be next to each other, which means that if you take the first one, you cannot take you cannot take the last one. Same thing if you take the last one, you cannot take the first one, right? So that's that. I mean, the only difference for this problem than the house robber number 2 is that, for the house robber number 2 here, you can take up to 2 to the power of n. Sorry, not. You can take to half of the n divided by 2 number of houses, right? Because you can take this one, and this one, right? But for this problem, you can only take exactly n divided by 3 number by this number of houses. You can call it the houses, or in this case, is a size of pizza, right? Because it says that every time we take one pizza, one piece, the other two-person will take two other pieces. So in total, you have to take exactly n divided by 3 number of pieces. So that's the difference. I mean, since we have these constraints here, right? I mean, we can still utilize the technique to calculate the house robber number 2 here, but only for this one we have to introduce a second dimension of our DP here, which means that for the DP, we have DP I and J, right? So the DP I means from 0 to i's slices. So this I is one base. So this is one base here from 0 to I slices, right? And we have taken like J's pieces, right? We have taken this J pieces, and the J is like the what? The J is the limit is n divided by 3, right? So that's why we have to kind of like this have this kind of two-dimensional dp state, and in the end we simply have this one kind of dp like the n, right, which is the size of the slices. And how about the j? The j is like the n divided by 3, right? So that's our final state, right? And the next thing is that we have to take care of this circle thing, right? Which means that we cannot take the first one and the last one at the same time. So I think for me, the easiest way to fix this one is that we have to basically do two of the DP. We have to do the DP twice. So let's say, for example, we have 1, 2, 3, 4, 5, right? We simply do a DP for 1, 2, 3, 4, 5 once, and then we do a DP for 2, 3, 4, 5, 6 one more time. Because with this one, since we have already removed the last one, we are making sure that no matter how we choose, right? Even though we choose number one and number two, sorry, this one and five at the same time, right? It guaranteeing that it will not violate our conditions. Same thing for this one, right? So then it's okay if we choose two and six at the same time. That's how we handle this like circle thing. Yeah, and with this two here, right? And then all the left is that we just simply do a nested for loop, right? And then the dp state transition function will be dp I j equals to what? So at the current I, right? At the current ith, um, we either choose to take the slice, or we don't take it, right? So it's like a zero, it's like a classic 0, 0, 1 uh, case, right? So if we don't take the current slice, it means that we have dp I minus 1 and j, right? Because since we didn't take the current slice, so j didn't increase. That's why we just have this one. If we decide to take the current slice, what's going to happen? So of course we have so this is going to be the max, right? Going to be the max of these two, right? So this is that we don't take this slice. The second one is we decide to take the slice. Again, if we decide to take the current slice, then it means that we can only start from I minus 2, right? Because if we take the current slice, then it means that someone will take the I minus 1. That's why we have to, the next state for us will starting from I minus 2. And of course, then now it's going to be J minus 1, because the previous, since we are currently taking a slice, then it means that we're going to have like J minus 1 state for this state, right? So that's basically the state transition function for us. And with this kind of analysis here, we can start our coding. So actually the coding is kind of surprisingly short, like I said, so we're gonna have like a n, right? So n is what mm, so the total number of slices we're gonna take is the n, is the length of slices, right? Slices divided by 3, right? So that's the first thing. And then, like I said, we simply call two, we're gonna have like, mm, all right, sorry, I just got a phone call. All right, let's continue. So I'm gonna have like a helper functions to help us calculate the maximum slices we can get, right? So we're gonna have like get max slices, right? So I'm gonna pass in like the slices, right? So this is actually a new slices, but I'm gonna still using the same variables name here. And assuming we have this kind of helper functions here, and I'm gonna call it help max get max slices, right? So I'm going to pass this slices dot from the second one to the last one, right? So that's the first one, and the second one is get max slices, right? And the other side, right? So this is how we do the slicing in Python, right? And so the first one is from the second one to the last one, and the 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 first one and the second one is from the first one to the n minus one, right? From and then among those two values, we get the maximum, right? That's going to be our final answer. And now all it's left is like this, right? So now we have I'm going to have like an m equals to the length of slices, right? And then I'm going to have a dp here. So at the beginning, everything is 0, right? So the second dimension is like the n plus 1, okay? Because anyway, when you take exactly this number of slices, right, from this pizza, and the first dimension will be the range of this number, right, of this new slices here. And then for I in range of 1 to m plus 1, right? And then the second one is for j in range of 1 to n plus 1. Okay. So like I said, the state transition function is simply the dp I j equals to what? Max. The first one is not picking the current one, which is the I minus 1 j, right? And the second one is to pick the current one. So to pick the current one, we're getting the numbers. We're getting the values of that slices, which is the slices dot I minus 1, right? Since this one is 1 based and the slice is 0 based, right? So and then we have like this dp. If we pick the current one, it's going to be the dp I minus 2, right? So because the I minus 1 will be the dp I minus 1 will have already been taken by someone else. And then after this one, the previous state will be j minus 1 because we're taking one. That's why the previous one is j minus 1. But okay, so here's something we have to be. This is like one of the corner case, which is since we're doing I minus 2 here, right, as you guys can see here, so we have the I starting from 1, right? So we have to do a simple check here. We only do this thing if the I is greater than 1, else 0, right? So let's do these things here. So it means that, if it's a first, basically if the I equals to 1, if the I equals to 1, we simply just use the slices. It kind of makes sense, right? Because if there's only one, if there's only one slices left, we simply just take that one, and there's no previously state for that, right? And when the I is greater than 1, then we can just use this state. And once we take the current I, so the previous state will be I minus 2 and then j minus 1, right? So in the end, here we can simply return the dp m and n. So this dp means the biggest slices, the biggest value we can get with the first m, basically with all the other slices available, and we pick n numbers of the numbers from the slices, right? And then here we have here we do this max, right? And then there you go. So if I run the code here, um, import system. Oh, here, missing one of the parentheses. Yeah, so it's accepted. I mean, real quick for the time complexity, right? I mean, it's pretty straightforward, right? We have a nested for loop here. That's why so the outer loop is m, right? So we have a m times n. That's gonna be the time complexity. And the space complexity is yeah, it's same for the O of m times n, but I think we can simply compress this space complexity from O of m times n to O of m because we only need two previous state. As you guys can see, we only need dpi minus 1 and dpi minus 2, right? That's why we can just remove this n dimension space complexity, but I'm not going to do it here. I'm only doing this main logic here. Yeah, I mean, just to recap for this problem real quick, so basically this problem is another format of a variation of the house robber problem. The only difference is that, for this problem, you can only rob exactly undivided undivided by three houses. And also we also have this kind of like the circle thing. And whenever we have circle issues, at least that's for me, I always use this kind of technique. Basically, I try to rob from the first one, from the second one to the last one, or from the first one to the n minus one, right? To the second of from the last one. That's how I handle this circle thing. And inside of here, right? Since we need to rob exactly n number of houses, that's why we need to have two DP state. And the not two DP state, I mean, I said that we could get rid of this one. I mean, we need to have like two for loops. I didn't mean to have two DP state, but we need to have two for loop nested for loops here. So the outer loop is the loop through all the slices from the first one to the last one, and the second for loop is to loop through uh, how many slices we can get among from this 0 to I slices. You know, we have some like invalid states along the line here, but those are not going to affect our final result because all we need is the dp the final one dpmn here, right? And this is kind of like a very classic technique, one of the dp type, right? Which we have two dp state two for loop here, and the outer loop is to loop through the slices, and the inner loop is to loop through the second dimension, right? And then here, and then we also have like this kind of classic 0, 1 scenario, which we either pick the current element or we don't pick it. And if we don't pick it, it means that the second the second one didn't change, right? And the number of slices we get didn't change. And then if we pick it, and then it means that we have to jump two more back, right, to get the previously state. All right, cool. I think that's pretty much it I want to talk about for this problem. And let me know what you guys think. And otherwise, I'll just stop here. Thank you so much for you guys to watch this video and stay tuned. See you guys soon. Bye bye.